Greatest common factors with prime factorization. Shun, 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 shun. All right, I am going to use the exact same numbers as in the last video. So 54 and 32. So we are going to go ahead and break these up by prime factorization to do the exact same thing, to find the greatest common factor. Remember, each of them is a story, and each of them have details in their story. But what is the biggest detail that is exactly the same? So guys, remember, prime factorization, you want to use prime numbers to break up each of these numbers so that all you have left are prime numbers. So let's go ahead and start doing this. So 54. Well, I know that I can break up 54 by 2, and 2 is a prime number. So 2 times what gives me 54? Well, off the top of my head, I don't know. But I do know that 54 is an even number, so it's gotta be something. So 54 divided by 2. 2 goes into 5 twice. Bring down. 2 goes into 14. There we go, 7 times. So 2 times 27. And 2 is definitely a prime number. Can't break it down any further, but we can break down the number 27. All right, and again, you just gotta kind of know your multiplication facts to make this a lot easier. But hopefully, if we do know our multiplication facts, you know that 27 can be broken up into the number 3, and 3 times what gives you 27? 9. So 3 is a prime number. We are done with that one. But now the number 9 can also be broken up. And what's the only thing that you can multiply 9 by? Well, besides 9 in itself. 3 times 3. All right. So here's our prime factorization. 2, 3, 3, 3. Okay. Now let's move on to the number 32. Same thing. What can we break that up by? Well, we know it's an even number, so it'll always divide by 2, but 2 times what? If you don't know off the top of your head, do the work. 32 divided by 2. 2 goes into 3 once. It gives you 2, subtract, bring down. 2 goes into 12 6 times evenly. So 2 and 16. All right, we can't break down 2 any further, but we can break down 16. Again, I can use an even number, 2. 2 times what gives us 16? 8. All right, we can't break down 2 any further, so that one's good, but I can break down 8. How can I break it down? Well, I can do 2 times 4. Again, 2 is done, and 4 gives me 2 times 2. All right, so I did my prime factorization. I've got 2, 2, 1, 2, 3, 4, 2, 2, 5. Whoops. I got 5 2's. All right, so now what do I do with these to help me find my greatest common factor? Well, you're going to look at your prime factorizations and what do they have in common. All they've got is the left has a 2 and then a bunch of 3's. The right side doesn't have any 3's, but it does have 1, 2. So guys, that's it. Because if you put them together, here's a 2 and here's a 2, that's it. Your greatest common factor is 2. All right, let's do another one. So let's do 27 and 63. Again, let's write up some of those factors for a reference. All right, so you just got to think. So what 2 numbers can multiply to get 27? Hopefully one of them is a prime number. And if we know our multiplication facts, we know that 3 times 9. 3 is a prime number, 9 is not. I can break it down. So what gets me 9? 3 and 3. And that's it. My prime factorization is 3 times 3 times 3 for the number 63. All right, so again, you got to know your multiplication facts. 7 and 9 get me 63. 7 is a prime number. 9 can be broken down into 3 and 3. And there's my prime factorization, 7, 3, and 3. Now, this is a little bit different than the last question. So this has a 3 and a 3 in common. It has got another 3 and 3 in common. We can't buddy up the other 3 and the 7. But we do know that 3 times 3 is 9. 3 times 3 is 9. So guys, that's it. That's your greatest common factor, 9. You have to make sure you multiply those 3 and 3s. Or what, and for any example, whatever you have that is in common, you can't just circle all the 3s. They have to have a buddy. So there's one matching pair, and there's 2 matching pairs. So 3 times 3 is 9. 3 times 3 is 9. So your final answer is 9. 9 is the number that they have in common. And guys, I took those exact same numbers, 63 and 27, and if you listed them out as a list of common factors, I can do the exact same thing. 1 and 27, 3 and 9, those are factor pairs. 1 and 63, 3 and 21, 7 and 9 are factor pairs. What's the number that they have in common? Well, yeah, they have 1 and 1 in common. They have 3 and 3 in common. And they have 9 and 9 in common. But remember, guys, it is called the greatest common factor. So you want the one that's the biggest. So 9 is the biggest number that 63 and 27 have in common.